Let's see how to create a spiral staircase in Roblox Studio. So let's create a new script, and let's create a new function to create our staircase. Let's start simple. First, I want this staircase to only contain one step, one stair step. So it's simply going to be a part. And now that I have this part, I should probably set its size. So I want the size of this step to be parameters to my function. So it's going to be the width of the stair and the height of the stair. And of course, later we'll use it for all of our stairs. So to set the size of my part, I can do just step.size. And this needs to be a vector3 object. So vector3 new. So the x is going to be the width of my stair, and the y is going to be its height. For the z value, I'll just go with 2. So I'm hard coding this value. Of course, you can change it to any other value or pass another parameter for it. Next, I want to set the parent of my step to be the workspace, so I can actually see it and add it to the world. And let's try to call our function so we can actually create our first step. So let me pass 10 as the width and half as the height. Now, the thing is that we want to create a spiral staircase. So it's not only one step, but a lot of them to create some angle. So let me add here 2 additional parameters. And these are going to be the required angles. So it's going to be the total angle for the entire staircase, and then the angle that each stair is going to make relatively to the previous one. Like how much of an angle we get for each consecutive step. So I'm going to add 2 parameters, the angle for one stair, one specific stair, and the staircase angle, which is the total angle of the entire staircase. And let's say that I want the angle for each of the steps to be 10 degrees, and the total angle for the entire staircase to be 90. And now it should be pretty easy to calculate how many stairs we're going to need. This is going to be the division of the total angle by the angle that we do each consecutive step. So the staircase angle divided by the stair angle, and this is going to be the number of required stairs. Now that I know how many stairs I need, let's create this number of stairs instead of just one. So for each and every one of them, I'm going to create a new part and then set its size and set its parent. And I'm going to use a for loop to create all of these stairs at once. But now all of these stairs are going to be created at the same position, basically on top of each other. What we probably want to do is to place them relatively to each other. So let's start by placing them each one a bit higher than the previous one. To do that, I'm going to use the C-frame property of our step, of our part. Using C-frame, we can set the angle of the part and also its position. Let's start with the position. So to use the current position, the current location, to calculate the new one, we can do it this way. So step.C-frame is going to be equal to the current value of the C-frame multiplied by cframe.new. And this way we can move the part relatively to its current position. So let's move all of the stairs a bit to the negative x, just so they are not created at the center, right at the spawn location. So this is going to be the x. And then for the y, I want it to be the stair height times I. And this way each stair is going to be positioned, is going to be located a bit higher than the previous one. As for the z value, I'm going to keep it simple at 0. And this way they will be located one on top of the other, each one at a higher position, but at the same x position and the same z position. I'm going to set them as anchored, and this way they are not going to be affected by gravity, they are going to keep their initial position. And if we are trying to run our game now, we can see our steps here. It's not that impressive yet, but they are here. We need to rotate our stairs, so to do that, we're once again going to set the C-frame of the part, and once again we're going to rely on the current value of the C-frame. But now instead of cframe.new, we're going to use cframe.angles, and this is what's going to allow us to rotate the stair. Now I only want my stairs to rotate around the y-axis, and this way they will stay on the xz plane but around the y-axis. And this is why the parameters that I'm going to pass to angles are going to be 0 for both x and z. But what's going to be different than 0 is the angle of rotation around the y-axis. This value is going to be the stair angle multiplied by I, because for the first stair we only want a small amount of rotation, and for the following one a bigger amount, and so on and so forth. And notice that the value that we need to send here needs to be in radians. But for me it's easier to think in angles, so I'm going to convert the value from angles to radians, and this can be done using math.rad. If we run our game now, we can already see a few stairs, and indeed altogether the staircase creates an angle of 90 degrees. If we now want each of the stairs to have its own different color, we can do it using the brick color property. And to set a random color, we can just use brickColor.random. And another change I want to make is to change the size of the stairs, because I think that it looks a bit better if we make the stairs a bit taller. So for each stair, we're advancing in the y-axis, like we're going up the height of the stair. So I want the height of the stair itself to be twice this height. So I'm going to multiply this by 2. This way we're going to get nicer, fatter stairs. So let's run our game now, and we can see our staircase, and it is colorful and nice. Let's try to increase the total angle of our staircase. So for example, instead of 90 degrees, which represents half a circle, let's say 440. And this is 360 times 4, so it's supposed to be like 4 full circles. And if we run our game now, we can see our full staircase, and indeed it's quite big, quite impressive, and also very colorful.